Hello students, good evening everyone. I hope all are doing well. Welcome to Infinity Learn by Sri Chaitanya. This is me Surya, your chemistry faculty from Infinity Learn. If anyone is watching this particular live, give me hi in the comments to mark your attendance here. Finally, we are moving to the last part of our chapter. We have already completed our solutions chapter. Here we are going to discuss some previous year questions based on the JEE Main exams from the chapter solutions. I hope you guys have revised to the topics you have covered in the last class. If anyone missed any of the videos, just make sure that you will be watching all the sessions, part 1 to part 7. It will be the concept classes for the solutions. Make sure that you will be watching all the recorded session after this class. Right, ready? Okay, I hope I am perfectly audible and visible to everyone. Is there any issues? Intelligent gamer. Voice is very low, right? Okay, I think let's start now. Okay, what do we have covered in the solution chapter? We have studied about the solute, solvent, their classification, solubility, Raoult's law, Henry's law. Then finally, we studied about the colligative properties, right? Here is your first question from the solution chapter. The question is, the quantity which changes with temperature is. We have studied about the concentration terms, right? How to express the concentration of solution in terms of different parameters. Among them, which one is the quantity that changes with temperature? That is your first question. Quickly give me the answer in the comments. Okay, what will be the answer for this question? Yes, option 1, right? Rexu Gupta, you are correct. Very good. So option 1, what is the reason behind that? What is the reason behind that? If you are comparing all the other factors, what is the reason behind molarities depends on the temperature? Okay, as we already know what you mean by molarity, right? It depends on the volume. Right? So yes, volume change, correct. In case of molarity, this depends on the volume. So obviously it will depends on the temperature. What about the other parameters? In case of mass percentage, molality and mole fraction, all are independent of the volume or depends on the mass given here. So we can say that they are independent of the temperature. So option 1 will be the correct answer here. Okay, 1 second, give me a moment. Audio issues are there. Voice not there. Voice not there. Voice issues. Students are coming like, huh? I don't know. They are saying there is no audio. We can't able to listen you. I will try to finish by 6. No worry. It is questions. No, I can just put it as homework. Okay, extremely sorry for the delay. I hope now I'm audible. Can you please confirm whether I'm audible or not? Yes, okay, thanks for the confirmation. Okay, here was our first question. I hope it's clear for everyone. Now let me move to the next question. Here is our second question. Okay, read the question carefully, then give me the answer in the comment box. A solution of H2SO4 is 31.4% H2SO4 by mass and has a density of 1.25 gram per milliliter. The molarity of the H2SO4 solution is m in nearest integer. Given the molar mass of H2SO4 as 98 gram per mole. What will be the answer for this question? You need to find out the molarity. Okay, try to solve this problem. Weight percentage is given here. From that, you need to get an idea about how molarity is collecting here. Okay, how we can solve this question? Yes, option 2 will be the correct answer, which means answer 4. Let's check how it is coming. So here it is given as 31.4% of H2SO4, right? Which means that 31.4 gram of H2SO4 is present in 100 gram of the solution. That is exact meaning of weight percentage, right? Then density is given as 1.25 gram per milliliter. So density is given as 1.25 gram per milliliter. We need to find out the formula to calculate the molarity, right? Molarity. So molarity is given as number of moles divided by volume in milliliter into 1000, right? So if you are putting the value here, the given mass by molecular mass will be the number of moles here. So I am taking here as 31.4 gram. 31.4 divided by 98, right? 98 is the molecular mass. Whole divided by volume is given as, we need to find out the volume from the density, right? Density is equal to mass by volume, or volume is equal to mass by density, right? Where mass is given as 100 gram here. So 100 divided by density is given as 1.25, right? 1.25 whole into 1000. You will get the answer is around 4.005. Round off it to nearest integer as 4. So option 2, 4 will be the correct answer here. Is that clear? Is that clear, everyone? Yes, fine. Now here is the next question. Yes. The question is, what happens to the freezing point of benzene when small quantity of naphthalene is added to the benzene? The question is related to our colligative properties. We have already covered all the colligative properties: relative lowering of vapor pressure, elevation in boiling point, depression in freezing point, osmotic pressure. Among them, which factor is affecting here? Yes, as we are covering the grade 12 classes here. I have already covered the solution chapter. That's why I'm taking the PYQs here in this session. And I have almost covered grade 11 chapters also. You can watch in the same channel, Infinity Learn JEE YouTube channel. It will be there. Right? Okay, what will be the answer for this question? What will happen to the freezing point? We have seen about the depression in freezing point, right? If a non-volatile solute is added to the solution or the liquid, what will happen to the freezing point? Decreases, right? Decreases. That is the depression in freezing point. So option D will be the correct answer here. I mean option 4 will be the correct answer here. I hope you understand. Yes, correct. Sanjit, you are correct. Now, let me move to the next question. Here is the next question. This is the match the following. Two lists are given here. You need to identify the correct options here. Read the question carefully. The list 1, some factors are given. You need to connect it to the list 2. I hope this table was visible to everyone. The first, it is Van Hoff factor. Then next one, Kf. Then solutions with same osmotic pressure. Last one, it is azeotrophs. The list 2, it is given as cryoscopic constant, isotonic solutions, normal molar mass divided by abnormal molar mass. The last one, solutions with same composition of vapor above it. Okay, Naveen, we have already covered grade 11 chapters. I have already covered 5 chapters. You can watch in our YouTube channel. It's already recorded. Okay, Sanjit, option 3, right? Okay, read the question carefully. Option 1 is the correct one, right? Option 1 is the correct one. Okay, just go through our channel. No, I have already covered thermodynamics, then classification and periodicity in properties, classification of elements and periodicity in properties, chemical bonding, then hydrocarbons. I have already covered these chapters in our channel in pure English only, so you can refer that. Okay, let us check here. Van Hoff factor, right? Van Hoff factor. How Van Hoff factor is connecting with the equation? That is equal to normal molar mass divided by abnormal molar mass, right? So A43 here, A43 here. Then Kf, what is the exact name of the Kf? Is the molar depression constant, right? Molar depression constant. If you are talking about the depression in freezing point, we will get a constant here, Kf, which is known as cryoscopic constant, right? Cryoscopic constant or molar depression constant. So B for 1. Then solutions with same osmotic pressure, as we already know, the solutions, two solutions having the same value of osmotic pressure is known as the isotonic solutions, right? Isotonic solutions. So C stands for 2 here. Then obviously last one, azeotrops is the solution with same composition of vapor above it, right? So D for 4. So as you can see, option 1 will be the correct answer here. I hope you understand. Clear? Okay, here is the next question. Again, as the following is related to the concentration terms. In the list 1, it is given as some of the concentration terms. You need to connect it with the list 2. Read the question carefully. Let me know the answer in the comments. First one, it is mole fraction, molarity, normality, and molality. And I hope the question is visible to everyone. Okay. Mole fraction, right? What do you mean by mole fraction? There is no any correct definition for the mole fraction given here. So we need to connect with the other options given here. Mole fraction value is always less than 1. Always less than 1. If you are taking the sum of mole fractions, right? Chi A plus chi B. If you are taking two components A and B, then chi A plus chi B, the sum of mole fractions should be equal to 1. It should be always less than 1, right? So A for 2 here. Then molarity. How we can define molarity? The number of moles of solute present in 1 liter of the solution or 1000 milliliter of the solution, right? So B for 4 here. Then what about C? Normality. The only difference between normality and molarity is that in the case of normality, it is equal to the number of gram equivalents of solute present in 1 liter of the solution, right? So here C for 1. Then the last one, D, molality, right? The number of moles of solute present in 1 kilogram of the solvent. 1 kilogram of the solvent, right? So D for 5. So which option is matching this? Which option is matching this? A2, B4, C1, D5, which means option 4 will be our correct answer. Yes, Sujit Tiwari and Sanjeev, correct. Very good. I hope you understand. Now let me move to the next question. Okay, this is a numerical question. There will not be any options given here. You need to calculate here. So, a solution containing 2 gram of a non-volatile solute in 20 gram of water boils at 373.52 Kelvin. The molecular mass of the solute is dash gram per mole, and it is given that water will be boiled at 373 Kelvin and Kb is given as 0.52 Kelvin kilogram per mole. Ritika, our online studios are here in Hyderabad and offline centers are in Lucknow, Nanded, Bihar and everywhere. These are the 3 offline centers for Infinity Learn. Okay, what is the answer for this question? I hope you guys are solving the question. Rishabh, 100 gram per mole, right? Let's take the answer. What is the answer here? It is, yes, you are correct. Very good. Yes, 100 is the correct answer, right? Yes. So how we can solve this? It is related to the delta TB value, right? Elevation in boiling point. So it is given as whenever 2 gram of a non-volatile solute is adding to the 20 gram of this solution, right? 20 gram of the water, it boils at 373.52 Kelvin, which means that TB value is given as 373.52, right? TB is given as 373.52 Kelvin. Then, and the TB naught value, that is the pure solvent value, is given as 373 Kelvin for water, right? So how we can find out the delta TB value here? How we can find out the delta TB value here? So delta TB is equal to TB minus TB naught, right? TB minus TB naught. Don't get confused with the values given here. So 373.52 minus 373 is equal to 0.52 Kelvin, right? 0.52 Kelvin. Then there is a simple formula to calculate the molar mass of solute. In the case of elevation in boiling point is that right? So Kb is our elevation constant, which is given as 0.52. So 0.52 into W2 is the weight of solute given here, that is 2 grams. 2 divided by, again 0.52 is the delta TB value here. 1000 divided by W1 is the amount of solvent, that is our water, right? 20 gram. If you are solving here, you will get the answer is around 100 gram per mole. Clear? Okay, we have almost 15 questions. Okay, Manimala, what is your doubt? Okay, I hope you understand this question. Now let me move to the next question. Yes, here is the next question, which is based on the Van Hoff factor. When we are discussing about the abnormal molar mass or abnormal colligative properties, we have already seen the term Van Hoff factor. Here the question is, if BaCl2 ionizes to an extent of 80% in aqueous solution, what is the value of Van Hoff factor? Ritika, it is not about the hard exams. If you are really interested in it, if you are committed to the smart work, it will be very easy for you. Or generally, we can say that as compared to NEET and other exams, JEE is hard. But it's up to you. Okay, what is the answer for this question? Option 2, right? 2.6. Yes, correct. Very good. Rishabh, option 2 is the correct answer here. How we can solve this question? How we can solve this question? Okay, this is an electrolyte, right? Electrolyte get ionizes here. So we can say that BaCl2, when it is dissolved in water, it will be dissociated into Ba2 plus 2Cl minus, right? So that will be the number of ions forming is equal to 1 Ba2 plus 2Cl minus. That N is equal to 3 here. So there is a formula to calculate the Van Hoff factor. I is equal to 1 plus N minus 1 into alpha, where alpha is the degree of dissociation and it is given as 80%, right? 80%. So here 1 plus 3 minus 1 into 80%, I will be converting as 0.8 here. So 1 plus 1.6, that is equal to 2.6. So option 2 will be the correct answer. I hope you understand. Clear? Hi, hello Cobra CX. Okay, now let me move to the next question. Okay, here is the next question. if the boiling points of two solvents X and Y having the same molecular weights are in the ratio of 2:1 and their enthalpy of vaporizations are in the ratio of 1:2, then the boiling point elevation constant of X is m times the boiling point elevation constant of Y. Find the value of m in nearest integer. Hi Summer. Okay, try to solve this problem as we already seen about the formula to calculate the Kb value, right? Yes, Kb value by using the enthalpy of vaporization. Okay, what is the formula to calculate Kb here? RTB square m. M is the molality, right? Divided by 1000 into delta H vaporization. So this is the formula to calculate. As we already know, in the case of first solvent, it is in the ratio of 2:1, right? 2:1. And it is in the same molecular weight, so we can just neglect the concentration given here. So we can say that the Kb of X divided by Kb of Y is equal to Tb of X square, right? Tb of X square divided by 1000 into delta H vaporization of X to 1000 into delta H vaporization of Y divided by Tb of Y square, right? So Kb by Kby, we need to find out the answer given here. So the ratio will be m by 1 here. So m is equal to Tb square. What is the value of Tb is given here? 2:1, right? So 2 square. Right? Which is your answer? One second, there is a small mistake given here. Put the given values given here. So Tb square of X is given as 2, right? So 2 square into 1000 we can just neglect. So delta H vaporization of Y is in the ratio of X is to Y. So it will be 2 again, right? So 2 square into 2 divided by 1 into 1, right? So 4 into 2, that will be equal to 8. So our ratio m is equal to value of m is equal to 8 here, which means option 3 will be our correct answer. Clear? I hope you understand, right? Hi Siddhi. Ready? Let's go to the next question. So here is the next question. 0.004 molar K2SO4 solution is isotonic with 0.01 molar glucose solution. What is the percentage dissociation of K2SO4? Percentage dissociation of K2SO4. Okay, what is the answer for this question? How they are connecting with the Isotonic, I mean in the case of osmotic pressure. Okay, isotonic solution means the value of osmotic pressure should be same, right? Osmotic pressure, there is an equation, pi is equal to C RT, where C is the concentration, R is the universal gas constant, T is the temperature. If there is any association or dissociation of the particles, there will be one factor that is known as the Van Hoff factor, right? So we can correct this osmotic pressure colligative property by multiplying with the Van Hoff factor. So this will be our equation to find out the osmotic pressure. First case, it is about the K2SO4, right? First case is about the K2SO4. And the concentration is given as, I am taking pi 1 as here. I, we need to find out the value of I here, right? Van Hoff factor we need to find out. Yes, 75 is the correct answer. Very good, Cobra CX and Yash Raj. So what is the I value or Van Hoff factor for the K2SO4? K2SO4, right? It can be dissociated into 2K plus SO4 2 minus. So I is equal to 1 plus n minus 1 into alpha, right? So we need to find out the value there. So I into concentration is given as 0.04. 0.004. Then it is at the same temperature condition. So we can just neglect the values of R and T here. If you are taking the Van Hoff factor of glucose, is there any association or dissociation in the case of glucose molecule? No, right, because it is a non-electrolyte. There is no any chance for association or dissociation in the case of glucose molecule. So the Van Hoff factor should be 1 is here. So if you are multiplying here 0.01, then what is the value of I here? I1 of the K2SO4, it will be 0.01 divided by 0.004, right? What will be the answer here? What will be the answer here? Right?
So, what are the transformations we have seen? You see, f of x plus 2 means the graph will be lifted by 2 units up. F of x minus 3 means f of x minus 3. The graph will come down by 3 units. And f of x.
Okay, try to solve this. You will get an answer here. That will be equal to 1 plus 2 alpha. If you are solving here, alpha is the degree of dissociation here, then you will get the answer is around 0.75. If you are multiplying it with 100, you will get the percentage is around 75%. I hope you got the correct answer here. Here is the next question. What weight of glucose must be dissolved in 100 gram of water to lower the vapor pressure by 0.20 mm of Hg? Assume dilute solution is being formed. Given the vapor pressure of pure water is 54.2 mm Hg at room temperature, the molar mass of glucose is 180 gram per mole. What is the answer for this question? This question is based on the relative lowering of vapor pressure. We have already seen what is meant by the relative lowering of vapor pressure, how it is connecting with the concentration, I mean in the case of mole fraction. Apply the equation there, then you will get the correct answer. Sanchit, answer is around 3.5, right? Options are given here: 2.59, 3.59, 3.69 and 4.69. So option 3 will be the correct answer, that is around 3.69 gram. What you have to do here, the condition is given as assuming the dilute solution, right? Assuming the dilute solution. We have already seen the relative lowering of vapor pressure, that is equal to pure solvent minus pure solution divided by P0 is equal to mole fraction. If you are considering the number of moles, if you are considering the dilute solution, The mole fraction is equal to number of moles of solute divided by number of moles of solvent. Right. What is the value of P0 here? Pure water. It will be 54.2 mmHg, right?
Most important point, I tell you, all of you listen to me with some information related to JEE. You see, JEE Main, maybe 2027, maybe written by around 15 lakhs. 15 lakhs.
Okay, in the question it is given as, if you are adding 100 gram of, if you are adding a certain amount of glucose to the 100 gram of water, the vapor pressure is lowering to 0.20 mmHg, which means that the term P0 minus PS will be is equal to 0.20, right? 0.20 divided by P0 is the value is given as 54.2, right? 54.2. Then what is the number of moles of solute? That we need to find out, right? That we need to find out. Then number of moles of solvent, here it is 100 gram by 18, right? 100 gram by 18. Then what is the value given, are you getting here in the case of N? What is the value of N given here? Just calculate the value of N here, then multiplying it with the number of moles, multiplying it with the 180 gram. You will get the answer is around 33.69 gram of glucose. Clear? Is that clear? This is a method to solve this problem. Relative lowering of vapor pressure is connected with the mole fraction of the solute here. In case of dilute solutions, we need to calculate only the number of moles of solute divided by number of moles of solvent. While you are solving, you will get the answer is around 3.69 gram. We are multiplying the number of moles of solute into 180 gram. That is the molecular mass of glucose here. I hope you understand. Clear? Okay, here is the next question. Which one of the following statements regarding Henry's law is not correct? Try to find out the answer here. It is related to the Henry's law. We have already seen how Henry's law is connecting the solubility. Vapor pressure is directly proportional to the mole fraction. Then vapor pressure is equal to Kh, Henry's constant into mole fraction. How they are connecting here? Okay, what will be the answer here? Yes, Rishabh, you are correct. This is 54.2 minus 54, which is already given in our question as, where it is, yes, 0.20, right? 0.20. So we don't need to calculate it again. It is already given as the value of P0 minus PS as 0.20 mmHg. So just calculate you will get the correct answer. Okay, what is the answer here? Option A, right? Option A. Option is higher the value of Kh at a given pressure, higher is the solubility of the gas in liquids. As we already know in our Henry's law, right? Henry's law, P is equal to Kh into chi, right? So if you are taking the value of Kh here, that is equal to P by chi, right? P by chi, or the concentration. If you are taking at the constant pressure, if the pressure is taken as constant, this will be in the inversely proportional relationship, right? Inversely proportional, which means that as the Kh value increases, the concentration decreases and vice versa. So option 1 will be the incorrect one. Higher the value of Kh at a given pressure, lower will be the solubility of gas in liquid. I hope you understand. Now let me move to the next question. Okay, here is the next question. Freezing point of a 4% aqueous solution of X is equal to freezing point of 12% aqueous solution of Y. If molecular weight of X is A, then what will be the molecular weight of Y? How they are connecting? Try to solve the problem. Now let me know the answer in the comments. Two solutions are given. Okay, freezing point of a 4% aqueous solution, right? 4% of aqueous solution. What do you mean by 4% here? 4 gram of X in 100 gram of solution, right? 100 gram of solution. Right? Okay, this is the relation given here. Delta T of X is equal to Kf into, where 4 is the mass of the solute, that is given as 4 gram in the case of X. Then M2 we need to calculate, right? M2 we need to calculate. Yes, into 100 by, sorry, 1000 by 100, right? 1000 divided by the given weight of the solvent here, it is 100. Similarly, in the case of 12% of Y, we can written it as Kf into 12 by M of Y into 100 by 1000. 1000 by 100. If you are solving here, you will get the answer is around the delta TF of X divided by delta TF of Y Okay, try to solve this. You will get the value of freezing delta TF of Y is equal to 3 into delta TF of X. And the weight of X is given as 3 here, right? Yes, A here, so it will be equal to 3A. I hope you understand. Try to solve the problem, then answer will be equal to the weight of Y is equal to 3A. Okay, here is the next question. When 3 gram of a substance X is dissolved in 100 gram of CCl4, it raises the boiling point by 0.60 Kelvin. The molar mass of the substance X is gram per mole. It is given as the Kb of CCl4 is 5 Kelvin kilogram per mole. What will be the answer for this question? Question is based on the elevation in boiling point. Try to solve the question and let me know the answer in the comment box. Okay, what are the data given here? When a 3 gram of a substance X is dissolved in 100 gram of CCl4, it raises by the boiling. Raises the boiling point by 0.60 Kelvin, right? So the value of delta TB is given as 0.60 Kelvin. Then what is the another data given here? The Kb value as 5 Kelvin kilogram per mole, right? So the weight of solute is given as, weight of solute W2 is given as 3 gram here. Then the weight of solvent W1 is given as 100 gram here. So put the value of delta TB here, you will get the answer is around. We need to find out the molar mass of substance, right? We need to find out the M2 value here. If you are getting the answer like this, delta T. Kb by delta TB into. Put the values here. Kb value is given as 5 divided by delta TB is 0.60 here into W2 is, yes, W2 is given as 3 gram, right? 3 gram into 1000 by 100 W1. So if you are solving here, you will get the answer is around 250. So option 1 will be the correct answer here. Yes, Rishabh, you are correct. So what you have to do here, the elevation in boiling point, just put the equation as delta TB is equal to Kb into W2 by M2 into 1000 by W1. By solving here, you will get the value of M2, that is the weight of molar mass of the solute as 250 here. I hope you understand. Okay, here is the next question. Identify the mixture that shows positive deviation from Raoult's law. Positive deviations from Raoult's law. We have seen about the Raoult's law, right? How they are connecting with the vapor pressure. In case of positive deviation, it should be seen that the observed vapor pressure of the solution should be expected than higher than expected from the Raoult's law. So that is the case in the case of positive deviation from Raoult's law. So what will be the answer here? These are the examples given from the NCERT. Option D will be our correct answer. Acetone plus CS2 carbon disulfide. Just refer our NCERT. You need to keep in mind about all the examples for positive deviation from the Raoult's law, negative deviation from the Raoult's law, and the examples for ideal solutions also. So option D will be here correct answer. I hope you understand. Refer NCERT for the examples. Now here is the next question. The molarity of 0.2 normal Na2CO3 solution is. The molarity of 0.2 normal Na2SO3 solution is. Question is based on the relation between molarity and normality factor, how they are connected with the N factor and so on. Rishabh, just think about this CaCl3 plus benzene solution. Is there any chance for hydrogen bonding or something? Is there any chance for change in the vapor pressure? No, right? Just refer NCERT textbooks. So what is the answer for this question? Option D. Are you sure, Sanjit?